All right, the next set of four constructions starts off with perpendicular bisector. So perpendicular bisector is two words and it means two things. It means we're going to draw a line through this line that does two things at the same time. One of the things that it does is it crosses our original line at a 90-degree angle. That's the perpendicular part. And the next thing it does is it splits our original line in half. That's the bisector part. If we were just doing one or the other, let's say we were just doing a perpendicular line. So here's our original line. If it was just a perpendicular line, it could be way over here. That's a 90-degree angle. That's perpendicular. It does not split our original line in half. So that would be just a perpendicular, not perpendicular bisector. Now let's say we just wanted to do the other part. Let's say we just wanted to bisect it. So we're going to draw a line through this line that splits it in half. So it's going to go through that point right there. That could be this. This line splits our original line in half. It goes right through the middle of it. However, it is not at a 90-degree angle. So it has to be both. It has to be perpendicular and it has to split the line in half. So to do that, you follow these 5 steps. The first thing you do is you put the pointy end of your compass, that's not the pencil end, it's the pointy end, on one end of your original line segment. And then second thing is you open up that compass so that the pencil is more than halfway down the line. So this is the pointy end, this is the pencil. You open it up so it's at least more than halfway. And then you draw arcs. You basically draw a circle like that. Okay? The reason that step 2 is important is because step 4, we're going to stick the pointy end over on the other side of the segment and draw the same size circle as this. So if our compass was this big, it's going to be that big still. So if we did not make the compass slightly bigger than halfway in our second step, we'd have 2 circles that look like this. We would have 2 little teeny tiny circles. They might be the same size, but they do not intersect. And the whole point of step 2 is so that step 3 and step 4 make circles that intersect. All right, so they got to be, the radius of the circles have to be the same, and they have to be more than halfway, so about somewhere in here. All right, if they're too little, they're not going to intersect. So we want to make circles that are the same size around each end of our segment, and then they're going to intersect here and here. So step 1. Put the compass on the paper. Step 2, make your compass so it's more than halfway. Step 3, draw the arc. So it says arc, not circle. The reason that it says arc is we're only concerned with where these 2 circles intersect. So we don't really need these whole circles. So when they say arcs, you can forget about drawing this whole circle. We don't really care about all that. We just care about the parts of the circles that intersect. And then it makes the drawing a little less messy as well. So those are the parts of the circles called arcs that we really care about. Once you have those, you take your straight edge, you connect those, and boom, there's your perpendicular bisector. It's perpendicular, and it splits your original line in half. So that's perpendicular bisector for you. The reason it works is when you draw these circles, how's the best way to explain this? Let's say we just take a guess, and we think that's the middle, and this line's perpendicular. All right? That means any point on this line is going to be the same distance from here as it is to there, because it's the same size circle. All right? So those are radius of the same size circle. If we were wrong, if our line that we guessed was leaning a little bit to the left, then this line would be shorter than that line, and these would not be the same size circle. So the fact that we use the same size circles guarantees that these 2 radiuses are the same, and they meet right in the middle, right in between. if they didn't meet in the middle and we drew this line straight up and down, it wouldn't be bisecting it. Or if we leaned it, it wouldn't be perpendicular. So that's why the two same size circles like that work. The whole key is step 2, make those circles big enough so that they intersect. All right, so that's perpendicular bisector. Now we've got 2 more perpendiculars. One is basically kind of what I showed you before, where if we only took half of the perpendicular bisector and we just made a perpendicular line, that's what we're going to do next. So we're not going to worry about splitting this line in half. We're just going to worry about drawing a perpendicular line through it. All right. So you can do that in one of 2 ways. You can do that as a perpendicular through a random point that's not on the line, or you can do it through a random point that is on the line. All right, and both of these are kind of the same concept. With the point that's not on the line or the point that is on the line, what we want to do is find 2 points that are the same distance away from that given point. And then we just do perpendicular bisector. All right, so let's start with the one where we're going to draw a perpendicular through the point that's on the line. The first thing that we're going to do is just draw a circle around that line. I'm sorry, around that point. We draw a circle around there, and we know that this point right here is the same distance from this point right here because they're both radii of the same circle. So that segment is equal to that segment because they're the same radii. All right, so now essentially what we have is 2 endpoints of a segment, and now we can just draw the perpendicular bisector through there. We can open up our compass to here, draw an arc up there, draw an arc down there, flip our compass around, draw the same size arcs, connect it, boom, we've got our perpendicular going through that line. So once you have 2 points that are the same distance away from the point you're trying to go through, then you just follow the perpendicular bisector steps that I just showed you. That's why I want to show you the perpendicular bisector first, because that's how you're going to do everything today. That perpendicular bisector, those 5 steps are going to come into play for everything that we do today. There's just maybe a step before or a step after. This was a step before. If you're drawing a perpendicular through a point on a line, the first step before those 5 in perpendicular bisector is to draw a circle around that point. And really, it's the same thing if the point is not on the line. All we're going to do is draw a circle around this line, around that random point, but that circle's not going to work. It's got to be a circle that intersects this line twice. All right, so it's got to be big enough that it's going to intersect this. So that means you take the pointy end of your compass and the pencil end, and the pencil end's got to drop down below this line. So if your radius is all the way down to here, that means you're going to go around that point. You're going to intersect this line twice. Now we know that this is a radius of that circle. This is also a radius of that circle. So those 2 points are basically this line is right in between. If we drop a line straight down from here, wherever it crosses here, it's going to be the same distance away from these 2 points. So basically what we found were, when we did this, and we found these 2 points, that's what we just did here. These 2 points are what these 2 points are. Okay, so you draw a circle around the point you're given, whether it's on the line or whether it's off the line. Once you have those 2 points, then you follow the 5 steps of the perpendicular bisector. You take your compass, you put it on that point, you go more than halfway to the other point, you draw an arc up here, arc down there, then you flip it around, same size, wherever they cross, that's your perpendicular. So it's all about perpendicular bisector. When it's a perpendicular bisector, you're given your 2 endpoints. All right. When it's a perpendicular through a point on the line, you have to find those two endpoints. When it's a perpendicular through a point off the line, you have to find those two endpoints. So it's all about these two endpoints and drawing an arc around each side and connecting that. That's perpendicular bisector. You follow those same steps here and here, you just got to find these 2 points first on those ones. So hopefully that makes sense to you. All right, now an equilateral triangle is essentially the exact same steps as a perpendicular bisector, except for that all-important step 2. Step 2, where we make the compass more than halfway. Now we're going to make that compass the whole way. We're going to set the pointy end here and the pencil end all the way over here. We're going to draw a circle around that. So our original line is the radius of that circle. Then we're going to flip it around our compass and draw the same size circle with the pointy end here and the pencil over here. So we've got two circles that are exact same size. They both have our original segment as its radius. And they intersect up here and down there. We're just going to worry about one of them. This intersection right here. Let's look at the first circle we did that had the center right here. This is a radius of that circle. This is also a radius of that circle. So these two sides are the exact same length because they're radius of the same circle. This is the center of the left-hand circle. That's a radius of it. So is that. They're the same length. Flip it around and look at this circle on the right now. This circle on the right has that as a center. This is the radius of that. This is also a radius of that. So there you go. All three of those sides are exactly the same. That's an equilateral triangle. So you make an equilateral triangle the same steps as perpendicular bisector, except step number 2, you don't just go more than halfway, you go all the way to the end. And then that guarantees that these two lines are radius, same length as that. All right, if you don't go all the way to the end, and you just follow the steps of perpendicular bisector, and you just go a little bit more than halfway, and say you go to here, draw that circle, and then you come over here and you draw the same size circle around this one, and you try and say that this is an equilateral triangle, I'm going to say no, that's not true, because this is a radius of this circle, but this one is not. It goes all the way to the edge of the circle and beyond. So this would be an isosceles triangle. These two sides would be the same, but the base would be longer. So to get these two sides to be long enough that they're the same length as the base, you got to open up your compass all the way to the end. All right, so that's the difference between equilateral triangle and perpendicular bisector. Step 2, open up that compass so it goes more than just halfway, it goes all the way to the end. Now you've got an equilateral triangle. So those are the 4 things that I wanted you to know today. Perpendicular bisector first, because we use that in the other 3. And the other 3 are perpendicular through a line and a given point off the line, perpendicular through a line through a given point on the line, and then a special perpendicular bisector where our circles are opened up all the way to the end. And then you get an equilateral triangle. So those 3 things, 4. Hopefully that makes sense. I'll go over it more in the first 10 minutes tomorrow.